by, you can just turn it a bit to the left. A bit more. That looks good. Just be careful when they say unlimited, they never mean unlimited. In the small print there's always a limit. So like when I got my home internet it said unlimited broadband, but in the
broadband is limited over here?
Yeah. So no, it's limited in most places. It's just the limit is going to be different. So for example, for my package it says it's unlimited, but really it's 300 or 400 gigabytes. If you go over this, they'll start calling you. One of the students here went with UPC, and it's also unlimited, but once you go past 1,000 gigabytes, which he did, they call you. I think it was mostly downloading PlayStation games. He had his PlayStation modified to allow for, shall we say, acquiring games without paying for them. We won't use any language like this. Okay. So anyways, there's always a limit.
Is there a limit? I don't think there's a limit.
No, trust me, if you use enough, someone will call you. That limit might be 10,000 gigabytes, but at some point, if you use enough, somebody will call you saying, what are you doing? Some people are very determined though. You know, if you're using a lot of torrents, uploading and downloading, like Blu-ray movies, what's a Blu-ray movie, like 20 gigabytes or something? You'll get to it pretty quick, you know. Yeah. But I know none of my students would use programs or torrents or Pirate Bay or anything like this. No, I know this. Yeah.
Not even on our computer.
Yes. Yeah. Okay.
Sorry?
Yes?
This is the same.
Yeah. Next lesson, can you look up? So we're going to have a look now at what's called the sine rule and the cosine rule. Who is that? Were you asking me about the cosine rule? Yeah. So we're going to do the cosine and sine rule now. Okay, so first, previously we have the sine, the cos and the tan. The only problem with these rules is that they only work for right angle triangles. Sine, cos, tan, right angles only. So now we need a rule that can work for any triangle. So let's start off with the sine rule. So let's say we have a triangle, and we'll call this side A, B, B, C, C. So this is for any triangle. Let's see what rule we can make. Firstly, I'll draw a line here and call this H. I can say sine A equals, what does it equal? Sine A?
Sine A over equals sine.
No, sine A. H over B. And what's sine B? H over A. So H equals B sine A, and H equals A sine B. So you can say B sine A equals A sine B. So you can say sine A over A equals sine B over B. Or likewise, sine C over C as well. You can also write this upside down if you want. You can also say A over sine A equals B over sine B equals C over sine C. This is called the sine rule. Okay, so write this one down. This is our first rule, the sine rule. In a moment, we'll do the cosine rule.
the same.
Okay, do you have that now? Do you have that yet? Let's have a look at the cosine rule. So same deal, we have some triangle. A, B, B. Well, let me think which way I want to. Yeah, no, I will call this one A. Okay. So the proof looks similar. Again, we'll draw a line straight down here and call it H. Yeah. And this time what's a little bit different is I'll call from here to here X. And what would this piece here be? How big would that be? C minus X then. So we can make two Pythagoras equations here. We can say x squared plus h squared equals c squared. And c minus x squared plus h squared equals a squared. So far this is okay? We can minus. I'll do the bottom minus the top. So I have c minus x squared minus x squared equals a squared minus b squared. So I get a squared equals b squared plus c squared minus 2cx plus x squared minus x squared. So what I did was I just took the b squared to the left and then I also expand the brackets here and I'm left with this.
Plus x squared minus x squared, that's the expansion of the bracket?
Plus x squared minus x squared.
Oh, that's the minus x squared, okay, yeah.
You're down to 1.
Okay.
Use it wisely. Okay. So a squared equals b squared plus c squared minus 2cx because they cancel. Let's look at what x is. We can say cos A equals x over b. So x equals b cos A. So we get a squared equals b squared plus c squared minus 2bc cos A. And this is the cosine rule. Again, it can be written slightly differently. You could also say b squared equals c squared plus a squared minus 2ca cos b. Or you could say c squared equals a squared plus b squared minus 2ab cos c. No. The cosine rule. Okay, please write this down and then we'll have a look at some examples. Continue. Yeah. Okay, so what we're looking at in this lesson is practical problems. We want to use sine and cosine rule to solve practical problems. Look at my beautiful pictures I drew. So happy. Right. I drew them all except this one, if you're wondering. Let's see. So this is very, very common in the exam. They give you some story and they want to find something. So here's a common example. I'll change it in a moment, don't worry. So, something like, I don't know, a boy looks up at the top of a mountain and the angle it makes is, we'll say, 45 degrees. Then he moves closer and he looks up again. Yeah, from his feet. Keep the picture easy, 50 degrees. He knows how far he walked. Maybe he walked 10 steps or whatever. So maybe, whatever, we'll say the distance he walked, we'll say 100 meters, for example. Because maybe he travelled, like, I'll give you an example. In Ireland on the motorway, when you see this sign, it means 300 meters until the exit. And then when you see this sign, it means 200 meters. So if you walk between these, you know it's 100 meters. So I'm just saying he can easily know how far he walked, and he can measure the angle. There is a very simple device to measure the angle when you look at something. It's called clinometer. A clinometer lets you measure the angle. So he can easily know these three things. But from these three things, he can do something rather amazing. He can actually calculate the height of the mountain. This is what we're looking for. So in blue is what we know. Red is what we want. And then green is what we find. Okay. So, this here is 90. If this is 50 and this is 90, how big is this angle here on this triangle? What is it? 40. Now, this mountain is kind of in my way, so I'm just going to delete it. Okay. So, this here is 40. If this is 50, how much is this? 130. If this is 130 and this is 45, how much is this? Is it 5? Yeah. Yeah, 5, yeah. So I have all the angles. Okay, let me call this side X. If I look at this triangle, should I use the sine rule or the cosine rule to get X? What do you think? We can use the sine rule. This is how the sine rule works. What you do is you put the side you don't know over the sine of the opposite angle, and you say that's equal to some side that you do know, which is 100, over sine 5. So can we get the X here? Yes, we definitely can. Do you know what? I won't calculate it just yet. I'll just write it as 100 sine 45 over sine 5. Now that I know the X, no, I'll do it. I'll get it later. Oops. How can I get the H? And remember, it's a right angle.
Sin 45 equal S over the...
Use X.
Not sine 45. You could say sine 50 equals H over X. So H equals X sine 50. Do we know X? Yeah. So this is 100 sine 45 sine 50 over 5, which is, so now I'll put in the calculator.
$621.
621?
No, 622.
Well, hang on, I'll get it exact.
621.50.
Yeah.
What? No.
No.
Something's very wrong. Ah! What? What am I typing in wrong? Oh! Yeah, hang on. Sine 5. I just wrote 5.
No.
That you just delete the 0
Yeah.
622 meters. This is a very, very, very common exam question. I've seen this actual one 3 times now, which is a lot because for the practical problems they're usually quite different. So please write this one down carefully.
So, is this Sine Rule practical problem that is shown in the exam?
No, sine and cos. It's just this one I only needed sine. Yeah?
So, the other practical problem would be cos.
Yep. Sometimes you need to use both rules, but usually in the exam we just need to use one of the rules, but not always. Yeah. Okay, did you write this down? Yes? Okay.
Who is Lee?
That's a real person, actually. That's a real person. There are some interesting ones here. I just want to do something with the cosine rule just for practice here. So, we use the cosine rule, like for example, let's say in this practical problem, here is the beach, and I don't know, there's a boat out here or something like this, and there's one person here and one person here. I don't know. You're confusing me. One person gets off the boat here. One person gets off the boat here. This person swims 100 meters, and then this person here swims 200 meters. And this angle here, we'll say, is 45 degrees. What is the distance between the two of them here on the beach? So we'll call this x. So this is an example of the cosine rule. The cosine rule is a bit like Pythagoras. What you say is the missing side equals the side you know plus the side you know minus twice the two sides cos the angle in between the sides. But don't forget the square root. 280.
How much do you get now? We are going to get to it.
I get 147.
Yeah, I got one.
Yeah.
What is wrong with me today? Oh no, actually I know what's wrong with me. Right, what did I type in wrong?
Go back.
147.
Question 5, could you explain it?
5. I'll have a look at it. Just give people a chance to write this down. Okay. Let's have a look at what 5 is about.
What is London?
It's a place.
What one are we talking about?
5.
No, it's a person.
Mandana.
Oh, sorry, I thought you were talking about this dude. Right. Let me zoom in a bit. Al-Biruni, I can't remember what country he's from. Anyways, this is an ancient story. While he was staying at Nandana, which is just a town as far as you care, he worked out how big the earth was. Pretty good going considering this was 600 years ago or something like this. So how did he work out how big the earth was? Well, what he did is first he worked out the height of a nearby mountain. Now you just saw a couple of minutes ago working out the height of a mountain is not too difficult to do. So we can easily imagine that he worked out the height of the mountain. Then what he did is he climbed to the top of the mountain, and as he was on the top of the mountain he looked down to the horizon, to the edge of the earth. He looked down to the horizon. So that's what this angle is here. It's him looking down to the horizon. And he measured this angle. So what he knows this height of the mountain, it was 321 meters. Of course he didn't use meters, but it was 321 meters in today's units. He measured the angle. The angle was quite small, 0.567 degrees, because you only have to look down a little bit.
Angle between what and what?
This angle.
Yeah, between what and what?
How far you have to, his hand is horizontal,
Yeah.
and you have to move it down to point at the horizon. So it's like the declining angle.
Oh, his vision and the horizon?
Yes, his horizontal on the horizon. It's here, it is in the picture here.
Okay.
He looks straight out and then points down until he sees the horizon.
Okay.
So, you know this, and you know this. Knowing these two pieces of information, it's enough to work out the radius of the earth.
Oh.
That's the question you have to do.
That's
No, you're that's what you have to try and figure out. There is enough information in that diagram to work out the size of the earth.
was
He was extremely close. I think it was 1% error. Maybe less. Like I said, 600 years ago, not bad. Okay, that's number 5 then. If you want, you can start these now. I need you to do all of them because this is a common exam question and you don't know what it's going to be like in the exam because they could ask you any story. If you want, you can try them now, and if you want, you can actually start with number 5 since we're talking about it. Okay? So start these now.